Sometimes, even in the world of programming, accidents can lead to incredible discoveries. Well, during building a Pong game, I stumbled upon something unexpected like that. Instead of fixing the mistake right away, I decided to get creative. I used this error as an opportunity to write my name on the Pygame window, which is what I will be showing you in this tutorial. So now you too can write your own name on the Pygame window. To start with the initials, I will need my width to be 1050 pixels and height to be 600 pixels. But before that, I'm just going to go ahead and type pygame.init. This basically initializes the module before using it. You will have to do it every single time before using the module itself. Now let's define the width, comma the height, which will be 1050 pixels, comma 600 pixels. Now I'm going to create the main window. This statement will create a blank window with the specified dimensions, and the statement is pygame.display set underscore mode, like that, and inside this we will specify the dimensions, width, comma the height. So this should create a blank window, but I also want to ensure that the quit button is going to work. So this is where I define the main game loop. Run is equal to true, and put it inside the while like that. Then I'm going to type and check for the events. So for event in pygame.event.get, like that. If i.type events.type is equal to pygame.quit, then we can simply make run as false. So we should be able to see a blank window. I will just take out these blank lines first and run our currency. And the quit button should also work. It does. Nice. So what I'm going to do now is to set up all the initial requirements. We will require 4 circles and the respective positions of the circles, the starting positions and the starting velocities of those circles. So everything has to be defined inside the main game loop because they will be constantly changing. So circles will be circle 1, and it will be circles x coordinate, comma circles y coordinate. I will put this inside a tuple like this. We'll copy the statement and paste it 3 more times and just change the numbers. And 4, like that. Then what I'm going to do now is to define the initial positions. Everything will be 0 at the start. Circles initial positions will be circle underscore x1, comma circle underscore x2, x1, I'm sorry, y1 will be equal to 0, comma 0. I'm going to copy the statement again and paste it 4 times. 1, 2, 3, like that. And just change the numbers. Now we can define the initial velocities, which will again be 0. Velocity of x1, comma velocity of y1, and they're going to be 0 at start, like that. I'm going to copy the statement again and paste it 3 more times and change the numbers, like that. So we have all the initial setups. Now we can start with the ball's actual appearance and the movement. So to see the circle appearing on the screen, we will need to use the draw statement. So for this, I will define a new section, and so this I will type in pygame.draw.circle, and we will need to mention where are we drawing the circle, which will be the window, and we will need to specify the color next, then the dimensions, which will be circle underscore 1, because we have defined it over here. Actually, this should go above the circle section, so I'm going to cut this and paste it here, like this, Control V. And we will also need to mention the radius, which will be, I will put this inside the circle section itself, which will be 15 pixels, like this. Good. And now I will define the color section outside the main game loop. Colors section. and I will define the blue color. It will be in the RGB format, so it's going to be 0, 0, 2, 5, 5, like that. And so for the initial positions, we will need to actually do a bit of math. So out of the 1050 pixels that we have, I'm going to subtract 150 as empty spaces at the respective ends. So if we subtract 150 from 1050, it's going to be 900. And we will have 4 letters, so I'm going to divide this by 4, which will be 225 pixels. And I'm going to give roughly 75 pixels to the starting position, so it's going to be 350 for the y coordinate, because I want 50 pixels of empty space at the top and 50 pixels of empty space at the bottom. So this will be the initial position. We should now be able to see the ball in the screen, but I will have to update the screen first to the latest statements. So pygame.display.update. Now we should be able to see the circle. On a currency, we do, but I feel like the circle can be a bit more down, so I'm going to change the y coordinate to 75 and see if that works. Fine, but I put in just another 5 pixels so that we can have a perfect position. That should do it. So yeah. Okay, so we want the circle to move towards the left first, and to do this we just have to subtract pixels from the circle's x coordinate and keep the y coordinate as static. So to achieve this, I'm going to start with giving an if condition to check for the circle's x coordinate. If circle's x coordinate is greater than or equal to, we have to specify the limit until which the circle has to move towards the left, in which in my case I'm going to keep it as 160 and keep the y coordinate as static. My one will be 80. If this is satisfied, then we have to make sure that the circle is moving towards the left, so we can define the velocity as negative 0.3, and that for the y coordinate should be 0. So what they should do is move the circle towards its left until it reaches the 160 pixel mark. Okay, so let's run our code and see. It doesn't very well. So I exactly know why this is happening. This is because first we will have to add the velocities to the coordinates itself. So I'm going to define a section known as movements. Actually, let's define a section for this as well. We will keep it as for the letter S, like this. And for the movements, we will have to add the velocity to the coordinates itself. So circle's x coordinate will be added with velocities x1, and similarly for the y coordinate as well. Velocity y1, like that. So we believe that the circle is going to move now, but it's not going to move. Now, why do you think this is happening? Well, always remember to troubleshoot problems like this. When you're working on position control projects like this, then you will need to print out the positions itself, like I'm going to do now. Print the circle's x coordinate, the circle's y coordinate. So this way you will identify where the problem is and why the coordinates are not moving. So we will run our code and see. And you see that 299.7 is achieved, but further movement is not achieved. So why do you think this is happening? Well, because we have kept this inside the main game loop, these are the initial positions. Each time the loop is completed and it resets, it also resets the position as well. So we don't want that to happen, we just want this to happen once. So we're going to keep it outside the main game loop, like this. And this way, the circle now should move towards its left until the pixel limit of 160. We will run our code and see. And it does. It just moved towards the left and stops at right around 160. Now we want the circle to make a sharp turn, and this time I'm going to keep the pixel limit as 30. So let's start with defining for the x-axis. So if 160 is greater than circle's x coordinate, which is greater than or equal to 130, this basically checks for the 30 pixels mark. And we will do that for the y coordinate as well. If 80 is less than or equal to circle's y coordinate, which is less than or equal to 110, then this time we will continue to reduce the circle's x coordinate, but we will have to increase the circle's y coordinate so that it kind of makes a diagonal movement. So velocities x1 will be same as negative 0.3, but that for the y coordinate will change to 0.3. like this. So now the circle should make a sharp turn until 130 pixels in terms of the x-axis. So moves towards the left and it makes a sharp turn. Beautiful. And now we want the circle to move down. So we have to keep the x-axis static and increase the velocity for the y-axis. So to do this, first let me just run the code. So after it stops right around here, you see that it has gone down below 130, but we have kept it as greater than 130. So this has gone below 130 and the if condition is no more satisfied and it stops right around here. Actually, when we have to continue, then we will have to check for the x coordinate to keep it static. We can't keep it as if circle's x coordinate is greater than or equal to 130 because this condition is not satisfied. It has gone down to 129.8. So what we will do instead is keep it less than or equal to 130. This way, this condition is satisfied and we're just checking for the y coordinate this time. So if circle's y coordinate greater than, let's keep it as 240 and check how it works. Then we will keep the velocity of x to be static and y coordinate just as 0.3, like that. So this time the circle should move down until the pixel gap or pixel limit of 240. So it makes a sharp turn and it doesn't move down. Why does this happen? Again, because we have kept this as greater than or equal to 240, it should be less than or equal to 240. So until the pixel limit, the y coordinate should be kept on increasing. So this time the circle should move down after making the sharp turn. So it moves towards the left, goes down, and it stops right around 240.2. Nice. So now you kind of understand why are we printing these positions continuously. We just have to troubleshoot the problems and this is the easiest way. Now again, we want the circle to make a sharp turn and this time it's on the right hand side. Again, I'm going to keep the limit as 30 pixels itself. So it's going to be the same thing over here, except for the fact that it has gone below 130, so we can't really have 130 here. Let's make it 129 because it has gone down below 130 and the fact that it is at 129.8. So 129 to 160 actually gives us 31 pixels, but we can change it in the y coordinate itself. So it will all make sense when you actually look at the code or look at the illustration itself. So what I'll know now is greater than or equal to circles y coordinate, which is greater than or equal to 240. So this time, now when you look at the code, you will understand that 30 pixels is the limit for the y coordinate, so that's where circle x1 will also stop. So what do we want to do? We will keep the velocity x1 to be positive since we want to move it to the right hand side, and same for the velocity y, which will be 0.3, like that. So now the circle should make a sharp turn towards the right hand side. So it moves towards the left, makes a sharp turn, comes down, moves towards the right, and it stops right around here. Very nice. So now we want the circle to make a straight horizontal line towards the right hand side, which means that the velocity in terms of the y coordinate will be 0. And I'm going to keep the cap at 270. So x1 will be 270. So why am I keeping this at 270? Because I want to give 30 pixels for the sharp turn that we're making every single time. So that if the sharp turn gives it 30 pixels, along with the 270, it aligns with the 300 pixels on the initial position. Again, this all makes much more sense when you look at the output of the illustration itself. So I will keep the y coordinate as well, the static position, should be greater than or equal to 270, like that. And velocity in terms of the x coordinate will be positive 0.3, and velocity in terms of the y coordinate will be 0. So this time we should see the ball moving towards the right hand side. So move towards the left, makes a sharp turn, goes down, makes a sharp turn, goes right, like this. So now what do we want to do? We want to make a sharp turn and it aligns exactly with this 300 position mark. To do this, it's just very simple. It's just the same process again. We will set the cap to 30 pixels, which will be 300. 200 equal to circles x coordinate, which is greater than or equal to 270. And similarly for the y coordinate, which will be 300 greater than or equal to circles y coordinate, which is greater than or equal to 270. Then we make both the velocities to 0.3, like this, and for the y coordinate to be 0.3, like this. So now we should see the circle making another sharp turn. So there is only 3 things left. The circle has to move down, make a left turn, and it should go straight towards the left hand side. Let's run our code and see. So it moves towards left, makes a sharp turn, move down, makes a sharp turn, right, down, and it stops right around here. So now the circle has to move down, make a sharp turn, and move towards the left. So now I'm going to move the circle 130 pixels down. So let's just keep the x-axis to be static and set the cap for y coordinate, which will be greater than or equal to circle underscore y coordinate, which is greater than or equal to 300. And we just simply increase the y coordinates velocity, so we keep x coordinate to be static, and we increase the y coordinates velocity like this. So now we see the circle further moving down, makes a left turn, moves down, makes a right turn, and it moves down like this. Again, just notice the fact that it goes above 300, so just have that in mind. And what we have to do is to make it a sharp left hand side turn. So if 270, because we're keeping the cap at 230 pixels, which is circle's x coordinate, which is less than or equal to 301, because it goes above the cap, and we can't get 300 because it is already above 300. And for the y coordinate, it is 460, 460, which is less than or equal to, actually greater than or equal to, circle's y coordinate, which is greater than or equal to 430. Again, 30 pixels sharp. So this time we are going to reduce from the x coordinate and increase on the y coordinate. So which will be negative 0.3, and for the y coordinate it's just 0.3. So the final turn has been made. We should see the circle just has to move towards the left hand side finally. So we just have to make a straight line, and the S is complete. So for the final lining, just remember that this is above the cap that we mentioned. It's just 270.29. So keep that in mind. Again, we just have to subtract x coordinate this time and keep the y coordinate as it is. So I'm going to keep the cap at 130. You can keep it whatever you want. I'm just randomly keeping it. Circles x coordinate should be less than or equal to 271, because it's just greater than 270. And let's just keep the y-axis as it is. So we don't need to have any specific parameters for it, just greater than 460. Then velocity in terms of the x coordinate will be negative 0.3, and y coordinate will be 0. So now we should see a full S appearing on the screen. And it does. Okay, so I'm definitely not convinced with the screen width and the dimensions being 1050 pixels, so I'm just going to make it 1300 and see if that matches. And there we go, that looks much more appropriate to draw 4 letters. Now I'm just going to do the same thing in writing the other letterheads towards the right hand side. It's just that we have to change the x coordinate position towards the right hand side. So first I want you to notice that there is a pixel gap over here, and it's just very appropriate to leave it this side as well. So first I want to check how much is that pixel gap, and it's 130. So I'm just going to subtract 130 from 1300, which will be negative 130, which will be 1170. So how much 1170 is greater than 300? 870. So the positions of the circle 4 will be 300 plus 870. And the reason why I'm doing this is we're just going to copy this fully and then paste it again. And then everywhere that we have used x, we're just going to add 870 pixels to. And that should be good enough for the second letter S in terms of the x position. And now we just have to change the numbers to 4. and also for the velocities. And then we will have to define the movements, which is just the same thing. You will copy this and paste it, and then change the numbers to 4. Okay, the final thing is to just draw them on the screen. Pygame.draw.circle. In the window should be blue, and we will do the same thing, which will be circle 4 and the radius. So now we should see 2 S's on the screen, and it doesn't. I'm just dumb, I just didn't define the Y position for the circle 4. Now we should be able to see the second letter S actually in position. Yep. Neat. In part 2 of this tutorial, I will finish off the other 2 letters by using 1 additional circle for each, making it a bit more intriguing and also ending off the animation of all the letters at the same time. It will be linked on your screens once it's released.